Okay, you hear a 200, so you know that's the original frequency, right? So that's the original frequency, but you hear it at, this is the shifted frequency, right? Is the car approaching you? Well, you shifted it to a higher frequency, right? So it's definitely approaching and it's not receding from you, right? So this is moving source and it's approaching, right? Because you hear the frequency at 223, which is a higher frequency, right? So the formula for that is the shifted frequency, which is the 223, right? Equals the original frequency, which is the 217, right? And then here it's the velocity of sound over v. And then in this case, it's minus the velocity of the source, okay? Because it's approaching. Approaching gives you a minus there, okay? So I'm going to plug this in. That would be 343 divided by, what would that be? 343 minus the velocity of the source, right? So just for fun, I'm going to, this is over 1, I'm just going to cross multiply. I'm going to go this times this equals this times this, right? So I get 217 times 343, right? These are parentheses here, right? Equals 223 times 343 minus US, right? Okay, so let's, okay, so we get 217 times 343 is 74,431. So I just did this. I multiplied these guys together. And then 223 times 343 is 76489. So that's this times this, right? And then this times this is just simply 223 times u, the velocity of the source, right? So now I'm going to subtract this from both sides, right? So 7, 4 minus 7, 6 equals negative 223. Ta-da. Okay, so 7. Okay, hold on. 7, 4, 431. 7, 4, 431 minus 7, 6, 489 is minus 2058 equals negative 223 US, right? So now I just divide, I just get rid of the minus signs, right? Divide both sides by 223. So divided by, and I get 9.228 287, right? So 9.2 meters per second, you definitely are approaching because you heard it shifted to a higher frequency, right? So 9.2 is good enough.